Hello everyone and welcome to today's webinar, Adventures in Crowdsourcing, Data Management and Governance for Better Crowdsourced Data Applications, the fourth webinar in the EDC5 webinar series. My name is Neelo Parvinashtiani and I'll be helping with facilitation of today's webinar. This webinar is being sponsored by the Federal Highway Administration in cooperation with the National Operations Center of Excellence, or NOCO. So if you don't know this about us, at NOCO, we provide resources on transportation system management and operations. On your screen right now, you see a useful links box, and we've shared several links with you on ways you can connect with us, including our YouTube channel, where you can access the previous webinar recording, and also a NOCO newsletter and NOCO Knowledge Center. So a few logistics for today's webinar. We are recording this webinar, and that recording along with the presentation slides will be available through the on-demand learning section of our website. All the attendee phones are on listen-only mode by default, but please stay engaged during the webinar by using the question discussion pod for any comments or questions that you have during the webinar. At the end of the webinar, we have dedicated some time to question and answer. So we encourage you to enter your questions as they come to your mind in the question discussion pod for our presenters. So that's all I had with the logistic. With that, I would like to hand it over to our moderator, James Collier, to start us off. James.
Okay, great. Thanks, Neelo. Can you hear me okay, Neelo? Just checking.
Yes.
Okay. Thank you. Welcome, everyone. I'm James Collier with Federal Highway Administration Office of Operations, and I'm the co-lead for this Crowdsourcing for Operations initiative with myself and Paul Joden. As Neelo said, this is the fourth installment of this webinar series, Adventures in Crowdsourcing. And our topic today is on data management and governance and how those topics can support crowdsourcing applications. So we have a great panel of experts today that will be sharing their experiences and perspectives on data management and governance and how they can support crowdsourced data. Those experts are Michael Schnurla, Chief Data Officer with the City of Louisville, Kentucky, Subrat Mahapatra, the Deputy Director for TISMO and CATS, Connected Automated Transportation Systems with the Maryland Department of Transportation. And of course, you probably all know TISMO is Transportation Systems Management and Operations. And then Benjamin Peychaud, Director of Information Research at AEM Corporation. Their full bios for each of our experts are available on the NOCO website, which I won't go through or read today so we can get into the content. So this webinar is brought to you by the Federal Highway Everyday Counts, or EDC program. This EDC program is a state-based model that identifies and deploys proven yet underutilized innovations, saving agencies time, money, and resources. So we're on round 5 of EDC. That's why we call it EDC5. And crowdsourcing for operations is one of the 10 innovations in this round. And we have a team on our crowdsourcing for operations initiative, national team. And our goal is really to help state and local agencies begin using or improve the use of crowdsourced data to operate their transportation system better. We're currently working with about 30 states across the country right now. So why crowdsourcing? Popular buzzword now, but we see crowdsourcing as a key technology by which to fundamentally improve agencies' abilities to monitor conditions on their transportation system in real time. And this capability to monitor conditions in real time is really the foundation of all operational strategies and responses. So any way you can monitor the system better, you inherently have better operational concepts and strategies. So crowdsourcing can really help an agency in terms of monitoring their system, expanding the geographic coverage of their capabilities, filling in the gaps where their detectors don't collect, and in areas where they don't have any coverage at all, like rural or suburban areas. It can reduce the information time lags between something happening on their roadway and the ability to detect it and respond to it. Some agencies are seeing the ability to detect incidents up to 10 minutes faster with crowdsourced data than their traditional sources. Crowdsourcing can help reduce the dependence and costs associated with roadside detectors and sensors and their associated communication systems. It can also overcome jurisdictional stovepipes because crowdsourced data is available really whenever and wherever people travel. And then finally, crowdsourcing can help implement more proactive operational strategies. So we see crowdsourcing as really a key solution and a low-cost solution to helping agencies improve safety and operations. There's a lot of different types of crowdsourced data. There's probe data, there's event data, where you notice individual events and when they happen. Traveler behavior data, and this is how, and we're starting to get at where people travel and the mode that they use. Social media is a type of crowdsourced data where you can capture sentiment on the road and agency performance, and this is the type of qualitative crowdsourced data. There's vehicular data that is starting to become available off of vehicles that are connected to the internet, where you can measure in real time heavy braking events, wiper status, and all sorts of things that the vehicle collects. This is a type of quantitative data, so crowdsourcing can be both qualitative and quantitative, and sometimes you get a mix of both, and that's what's really kind of indicated in the jelly bean jars there. Some are more pure quantitative, some are more pure qualitative, and some are mixed data sources. And so there's really a lot of different types of data that can be parlayed into information for transportation operations. In terms of application areas that we're seeing within the field of operations or TSMO, the most common ones we're seeing are using crowdsourced data for traveler information and incident management, but we're really seeing a whole host of really neat and innovative uses of crowdsourced data for improving agencies' ability to manage work zones, manage road weather events, manage maintenance, and identify things like potholes, traffic signal management as well. So there's really anything that an agency does in terms of real-time operations, crowdsourced data has the potential to help you. An important part of crowdsourced data is it's not necessarily a replacement for an agency's currently collected data sources. And this is where data governance and data management and the topic of today's webinar come in. Crowdsourced data has to be integrated in with your existing data sources in order for it to be useful as a supplement. And this integration is really important and how that's done. And in terms of like moving from a manual viewing of data to a process that's integrated within the agency's overall system of systems and decision support systems is really at the heart of data governance and management. So this is why it's an important topic when we talk about crowdsourced data. As part of our Crowdsourcing for Operations initiative, we have a number of resources that we're making available, such as this webinar series, Adventures in Crowdsourcing. We've done, this is the fourth one. We have a number of other ones coming up. You see there are some of the topics that we'll cover in the future on traffic signal management, back of queue applications, social media applications as well. We have a number of workshop slots that we will be making available throughout this year. There's a one-page flyer that we have that will be downloadable. So you just contact me or one of the members of our team if your state or agency is interested in a workshop. We're organizing a number of peer exchanges, the next one targeted in March, but we'll really go through the rest of the spring and summer. And then on-site technical assistance where we can provide more customized and specific assistance to what your agency's needs are. Okay, so that was just a quick overview of the Crowdsourcing for Operations initiative. At this point, there are a couple of funding sources available that you saw there, and some web links for more information. Some seed funding always helps. At this point, Nilo, go ahead and bring up the first poll question, and we'll get going on to the next speaker. So this is a poll question. We'll ask a few throughout the webinar here. This is one just seeing if you have any specific information in your agency or your region on specific applications of crowdsourcing that you're aware of and the data that's used by your agency. If you could type it in the pod there, that would be great. We're always hearing of new types of ways that crowdsourced data can be used, and so I'm always curious to see what folks are up to. So I'll just give a quick pause here if agencies or people want to type in, feel free. Yeah. Okay. Answers coming in. It's good using Waze reported pothole data to generate work orders. Yes, we're hearing of other agencies doing that as well. Monitoring compliance, dockless e-scooters and e-bikes, that's interesting. Signal retiming performance, that's good. If you don't mind, yeah, that's great. So I'll just give a few more seconds here and then we'll move on. Yeah, so we're basically crowdsourcing right now. Example of finding out from the crowd what and learning. So thank you for answering that. We'll have more poll questions as we go. Let's go ahead and close up the poll question, Nilo, at this point. And at this point, I will turn it over to our first expert, Michael Snerla from the City of Louisville. So, Michael?
Yep.
We'll bring up your presentation and take it away.
All right. Thanks a lot, James. So I'm going to talk about using some crowdsourced data and open source tools in government, but also the data governance we have behind that. Start with myself. So I'm kind of in the middle there. I'm the Chief Data Officer for the City of Louisville. I'm in the Office of Civic Innovation and Technology, which includes IT, and we report up to the mayor. So I'm kind of a data generalist, manage lots of data projects for the city internally and externally, and I also manage our open data program and a data governance team, which is 60 people from every department, sometimes 2 or 3 people from each department who work with data, and we get those people together, have them collaborate, give them access to tools, training. We write policy for the city, do a data inventory, align to data standards, et cetera. So I think that group, having a group like that has been really important with some of these efforts that I'm about to go over. So first one I want to cover is citywide traffic sensors and how they can be crowdsourced. So this is something that probably most of you are aware of, and just based on the recent survey, some of you are already using Waze data. So, but I want to give some examples about that. So with Waze data, we have 50,000 active daily users in Louisville. Your city, if you're larger than Louisville, probably has more than that. They have a Connected Citizens program, which is now rebranded as Waze for Cities. So you can look that up online, and that allows you to share data with Waze, and that updates their live map and their app. But it also gives cities, states, and federal governments near real-time data for jams that are passively collected and alerts which are actively submitted by users. So those kind of hit on James's probe and event types of crowdsourced data that he mentioned in his opening. So how do we use this data in Louisville? If we have a large event like a Derby Festival is something we have here. Thunder Over Louisville is a kickoff for the Derby Festival. We can use it after the fact to do post-event analysis to see how the traffic went and how we can improve it for the next year. We can look at jams after retiming or restructuring of a road, maybe a road diet, and see how it improved at different times of day or if there's any issues that we might have to tweak. We do also use it for pothole reports like some of the people mentioned in their surveys and compare it to Waze data. And we do find that the Waze data is reported more on faster roads and versus our 311 system, which is more local and slower roads. And then this was mentioned as well as an example for 911 calls, emergency response. Many agencies, our Kentucky State DOT uses this. I know Massachusetts DOT does and some other places as well, where they monitor the live Waze events to send out a response. And many times those calls come in up to 4 minutes before the Waze events come in up to 4 minutes before the call does, so we can get people out there a lot faster. And then we have some other use cases for the data internally. We can monitor quarter changes like I mentioned. We can look for faulty equipment, so if there's a jam that's showing up in consistently, the traffic engineers can look at that intersection just using the Waze data, and because of their knowledge of that, they can determine that, oh, there's a problem at the induction loop or the signal or something like that, especially if it's not a connected signal. And then we also use it for some of our Vision Zero analysis and real-time alerts and routing for emergency vehicles. And we are starting to do some citizen-facing notifications where citizens can get alerts if something's in their area from the Waze data that we get. So all that being said, I want to point out a solution that we built called Waze Warp, which is an open source tool that processes the Waze data. It's complicated to use that data sometimes. Some jurisdictions have spent hundreds of thousands of dollars to build a tool to make sense of that. We developed Waze Warp. It's open source. It's free. Over 80 govs are on board and 15 or so are using it right now. And it costs about $200 a month in just cloud costs. And what's interesting here is we had sponsors. So AWS was the sponsor. They paid a cloud web developer, Slingshot, to build a platform to the spec of multiple cities. So we were able to leverage private funding and development for the benefit of cities at no cost and build something that's open source. And then that tool we have linked up to Power BI, which is a nice free desktop tool that anyone can use, and that ties into that database, the Waze Warp database, and allows us to build these sort of visuals you see here and these analyses, and this is all available as well for free. So if you're running the Waze Warp program and you plug in this Power BI template that you download to your local instance, you'll get your data automatically visualized and analyzed. So that helps share the knowledge that that cities are working on in order to help every other city out instead of just doing it in our own vacuums. And one way we use this is we can replicate traffic studies. So we've abandoned paying for most of our $50,000 traffic studies and instead are using the Waze Warp Power BI tool combo. We also have a partnership with the University of Pennsylvania where we've given them access to some of the Waze data, and they've been able to do a predictive congestion model based on weather and time of day, month, and day of the year. So, and they've taken a lot of other built infrastructure pieces of information into that model, and that model and code is available at the URL there. I think these slides can be shared after the webinar, so you can get to that. And that was also built on the Waze Warp platform. And there's a little footnote here, Anchorage, Alaska deployed this whole platform from nothing to having it working and ingesting their Waze data in 30 minutes on a commercial airplane from a laptop. So they'd never done it before, and one guy did that on a plane. So it's pretty easy to deploy. And I just want to point out, related to crowdsourcing, is this, I think, many times this idea of open source development, like I mentioned with the Waze work program. And there's an organization called the Open Government Coalition, which is a network of government agencies where we build cloud hosted, usually open source projects together. So that's something for you to take a look at if you're interested. It's one of many open source tools and organizations and code bases that can be used for developing your crowdsourcing solutions. Another one to point out in the mobility space, which is relatively new, is the Open Mobility Foundation. So they're building tools on top of the MDS data spec that are also open source that allow cities to make sense of the scooter data for now that's coming in, and in the future other sorts of connected mobility. I just want to point out that our website is built on open source software as well, so basically it's free software. Many cities are using this, Long Beach and some others, many internationally, and there's a lot of other open source solutions out there, so you don't have to pay for complex vendor systems all the time to accomplish what you need. And last thing I want to point out is OpenStreetMap. It's a crowdsourced mapping data application. We in Louisville used it to import all of our building footprints into it, 415,000 buildings, and that data was not in there before, as you can see on the left, and then in the end we were able to add the building footprints, and that data is then there forever, and it's shown up in many other applications because there's many applications that rely on OpenStreetMap. So if you can get your local data, road data, structure data, street sign data into OpenStreetMap, it kind of pays dividends in the long run. So how did we do this? In Louisville, we've got a really great mayor. He's kind of created this data-driven culture and culture of innovation. So he's really all about data, all about innovation, all about trying new things, about collaboration. So it's easy to get started. Most of governments focus on the daily work, but he's allowed us to carve all of our time out for some breakthrough and innovation work. And our innovation department is kind of run like a nimble startup. We connect the dots. We don't really have a budget, but we still provide value and find future funding through grants and other opportunities. And so that's how the Waze Warp program was built. And then we're self-funded, so we've self-funded about 27 years of our operating expenses in the last few years, $14 million for our 4-person team. And as the next slide loads, I think it's about data governance. Yes, so this is back to one of our first slides about our data governance team, people who manage data from every department in the city working together to solve common problems. We want to use those people to expand our department's data capacity. So by giving them access to tools and training and having that network, it really increases what they're able to do on a day-to-day basis in their jobs and what sort of analysis and outcomes and dashboards and everything that they can do with their time. So we have training and events around that. We have working groups that focus on lots of different initiatives that we need to get done. They work on the data inventory for the city, which is cataloging all of our data assets and then publishing that to open data. We have a business intelligence group, which really focuses currently on Power BI, but we also have a data academy that teaches them other skills. We have an open data website that they manage, so all these data governance people manage the open data for their own departments. We have a data quality working group that's started and a data standards group that's already created some data standards about how we collect and store and share data. And then a badges program, which I won't get into here, but it's a way to reward all these employees for their work with their leadership and with the mayor. They basically get badges, kind of like Girl Scouts or Xbox achievements, to reward them for the work they have already done and maybe nudge them into other work that they would want to do. And we've had, I think, about 230 badges earned so far by our employees. And we also write policy for the city. So here's a list of some of the working groups that I think are important for the improved operation of our city. Our data inventory I mentioned, some data standards that we're aligning to. We have a data warehouse and ETL working group where we're building out that automation piece, which is really important, as you all probably know. Our open data policy needs revising and improvement, and there's a group that works on that. We have a data automation group and a data quality group now. So what's interesting is, we have that sort of, the hardest thing about this, I think, is the culture. It's not really the technical side of things. But if we have support from the top and the people that are doing the work understand the value of this, then it really helps drive that day-to-day and month-to-month support of these initiatives and moving us forward as a city in terms of data. So I think the culture is probably the most important part of all of that, and it's taken us really about 3 years to get to this point where we are now. So that's the end of my presentation. Here's some of my contact info and a link to our website if you want to go see some of these initiatives and look at our data governance group. It's available there. And I'll send it back over to you, James.
All right. Thanks, Michael. Impressive the way your agency does data governance and management, and I like the point at the end about culture being the most important part. So thank you for your time and presentation, Michael. Again, if you have any questions, go ahead and type them in the question/discussion pod, and we will answer them at the end as we have time. At this point, Nilo, if you don't mind bringing up the next poll question. So if you don't mind answering, quick question. So the question is, how do data management and governance practices affect crowdsourcing applications at your agency? And just, I guess, pick the one that you most closely identify with for your agency. So it's the range of fully supporting our development, somewhat supporting, they pose some obstacles, there are significant obstacles, or they totally prevent us from approaching crowdsourced data. So we're curious where you're at with your agency, or if you're a consultant, you can answer on behalf of your region or agency that you're familiar with working with. Seconds. Okay, looks like a range. The most answers somewhat in the middle, that they somewhat support our developing effective uses of crowdsourced data, but it could be better. So that's somewhat encouraging that it's not a total prevention. There are still some obstacles, but still getting some support. So let's go ahead and close that out, Nilo, and we will move on. Now we'll have Subrat Mahapatra from Maryland DOT speak about his agency's management and governance efforts and how their steps to use crowdsourced data more effectively. So Subrat, I'll turn it over to you.
Thank you, James. Can you hear me?
Yep, loud and clear.
Great. Well, good afternoon, everyone. I wanted to start by thanking Federal Highway and NOCO for hosting this webinar in this emerging area. And in the coming 15 minutes or so, I wanted to give a perspective from a state DOT and what drives the data management and governance conversation when it comes to crowdsourced data applications. So it's, you heard James talk about the federal perspective, and a lot of creative, very unique work is happening at a city level thanks to champions like Michael and some of the cool things that are going on. And what you would hear from us is these four basic areas as what is the department-wide governance efforts at MDOT? What is the MDOT State Highway Administration data governance and management structure for TSMO? Again, TSMO is Transportation Systems Management and Operations. We'll touch on the MDOT SHA GIS data governance, which is pretty mature in our state. And we will talk about the planned Waze data management and governance. Again, this is an area that we are getting into more and more and building off the successes that are happening with Louisville and other places, what does it mean and what does it mean from a governance standpoint? So with that in the context, I wanted to talk about Maryland DOT as a State Department of Transportation. We have 6 business units: the Secretary's Office, State Highway Administration, we have Transit, Port Administration, Aviation, and the Transportation Authority that is in charge of the toll system. So again, anyone who knows the Baltimore-Washington region knows how it's pretty well connected, multimodal transportation network that is in place, and a lot of multimodal activity occurs throughout the region, more in the central business districts, suburbs, and less so in the rural regions. And here is the accelerator, which is our performance management / business plan, where we operate our agency through tangible results and performance measures that are data-driven. When you look at data from a state DOT, it's data, and you are, as an agency, are trying to make strategic, tactical, and day-to-day decisions of data as multiple transportation business units, whether you are the State Highway Administration or Transit Authority, or Transit Authority, or Transportation Authority. So you can look at these data streams through multiple lenses. You can look at this data by mode, which is highway, transit, air, water, other modes, and the combination modes. You can look at it by function, whether it's a planning activity that you are going forward with, or engineering, operations, maintenance, or overall performance management of your program. You can look at it by performance area. So let's say safety, mobility. Clearly we talk crowdsourcing more in the context of mobility, but there are opportunities in the asset management areas as well. And again, by performance area, you could be looking at business transactions day to day, or administrative functions, payroll. So, and also from a source standpoint, here you have data that is generated by the agency through its own infrastructure, whether it's ITS infrastructure on the roadways or the business data, but you are also leveraging external data from your stakeholder partners, private sectors. So the essence here is you have a lot of way of looking at data, and when you look at a big organization like us with multiple thousands of employees working on mission critical projects that has different timelines and modes and complexities associated with it, you could see how complex that might become. So this is where we started putting a MDOT department-wide data governance and data hub concept. So this effort is a couple of years old, started with some big stakeholders, internal partnering conversations, people, staff from different TBUs, operations, planning, different business areas coming together to see what data governance look like. And this is a report that was published last year to basically set the stage for department-wide data governance and data hub. Again, I'm not insinuating that the concept of data hub is new or the data governance is not in place. There are subject areas like the TISMO area or the GIS area where there has been data governance in place for quite some time, pretty well established. But here this was a stab at taking a step back and looking at the overall picture with some policies. And here are the principles and dimensions to data governance. And here we go by the ASTO. ASTO came out with the 7 data principles. Again, I won't go through all of them. Folks are probably familiar with it. But we take the 7 data principles at heart, and working through the dimensions, you can look at people aspects, you can look at processes, and you can look at technologies. So looking at these dimensions and through these core principles, we develop the data governance plan. And from a data hub perspective, here is a conceptual framework. What we wanted to do was we wanted to have an official quote-unquote data set for the entire agency, bringing the transparency and validation. So irrespective whether you're making a planning decision or a business decision or a day-to-day operations decision, we wanted to make sure that we are using the same data sets for different purposes. And this is where bringing the private side, public side, research side data sources into a staging area with the concept of a data hub, and creating those data schemas, data marts to support all the applications that we could be using for multiple purposes. So this is a concept that is that we are moving forward with. And again, the whole good idea news there is we have some business areas where these concepts have been well vetted, and the idea is how do we take those from those successes to go to the next level. So I will talk on TISMO data governance and management as an example as how we are taking this unique structure. So anyone who is familiar with operations, again, the point of this slide, which is very, very busy, is if you look at any icon in this slide, it's probably a system or a subsystem, and there could be 10 different processes or technologies that could be supporting it. But the gist of this slide is when you're looking at operations and the data communications that happens, it's a system of systems. So you have travelers, multimodal, using different modes of travel. You have them reacting to their smartphones or their technologies, the private sector leveraging some of those data sources. You have the connected vehicle feeds. You have the traditional media, the next generation media, the Waze crowdsourcing. So you have that as a cloud. You have the traditional transportation management agency companies, whether it's the law enforcement or the medical profession or other businesses that react with travelers. And you have our core transportation network with the ITS devices and our own infrastructure, whether it's our radio towers, our centerline data, our dynamic message signs, our work zones, the signals, our chart incident management trucks, our fleet vehicles. So there is a ton of data coming from the transportation network. And then there is the decision support system to the far right, which is trying to integrate all of this information to provide the most meaningful insights and probably decisions for the agency and also for the traveling public. So if you look at this slide itself, you could see how complex this whole thing is. And that's where a detailed data governance and a management structure becomes very important. So what we did with leveraging a partnership with Federal Highway, we generated a data governance plan for TISMO. So we identified the key stakeholders and we created a data board, and we looked at mobility data. And folks are probably familiar with the capability maturity model structure. So we put all our data sets through the CMM framework. So the idea was some data is good for planning purpose, and some good data is good for operations purpose. There is a maturity scale. So depending on what the data stream is, whether it's a traffic volume or a traffic speed coming from NPM RDS or INRIX, those data sets are very stable at this point. So the maturity level is higher. The freeway side is more mature than the arterial side. So you get the idea how we took a tiered structure of evaluating the data streams that are there for different business purposes. And then we did this mapping. And the whole goal for this mapping was to have a framework where we look at these new set of data streams, whether it's the origin, destination, trajectory data, whether it's accessibility data coming from the e-scooters, so and the connected automated data streams. So the whole idea was, with this capability maturity governance structure, we started looking at where do we stand currently with a data stream with a certain business purpose, and how is it evolving, and what are the steps that are we taking as an agency or as an industry to get the ball rolling in the right direction. So this data governance helps us in moving the program forward in the right direction. So when it comes to crowdsourced data application, again, this is a subset of the total data that comes to us. There are primarily two uses. We use it for real-time operations, for overall system monitoring, traffic incident detection, incident management, active traffic management, integrated corridor management solutions. So these are the data streams that fire up our DMSs where you say travel time 10 miles, 10 minutes, or accident ahead, so on and so forth. But there is a greater use of these data sets from a performance evaluation standpoint and TISMO's decision making. This is where we archive the data and create visualization engines and algorithms to see what is this data telling us and how can we make better informed decisions. So to give a context, again, I want to preface that most of our operations data gets backed up with a collaboration with our University of Maryland at College Park. And the Regional Integrated Transportation Information Systems, again, many folks should be familiar with that visualization and data warehousing engine. We leverage those partnerships to store all the probe data and all the big data to power up our engine. So if you look at from a data management perspective, traffic events, this is how much gets generated from a storage standpoint every day. Traffic detectors, you're looking at 5 GB per day. Probe vehicle data is it's 550 GB per day. And we don't store video, but you can imagine once you start looking at video feeds and connected data feeds, you are talking about terabytes and petabytes of data. So the whole idea is having a scale of magnitude for the applications and archiving gives a perspective of what needs to happen from a data management perspective. So here are the elements of an effective archive. And again, I want to acknowledge University of Maryland for being that support cast for us for many, many years for us and for other DOTs and MPOs. So the idea is you have data and raw data gets post-processed through tools, and that leads to some fusion statistics and analysis and visualization tools. So the whole idea is you have an archiving component, and then there is a distributed component because you are mining years and years of data, real-time data that comes in that gets archived. So these are, again, I won't go through these list of databases. Some of them are traditional relational RDBMS, but some of them are NoSQL, NewSQL. And then there are distributing computing models out there that folks use, that experts use to basically generate the statistics in real time or near real time for us so that we can do visualization and data mining. I want to switch gears to talk about some of the geospatial data governance and management, and I alluded to earlier, thanks to the administration, statewide support from the governor's office and the leadership support, Maryland has been a unique player where it has created a GIS portal through the MDIMAP project. Where is this the open data portal where agencies can upload and interact with data streams that are validated and vetted. We have an extensive GIS data catalog that are not necessarily transportation data, but we also leverage data streams from other agencies. Again, the whole idea for us as end users, decision makers, is how can we bring the GIS data layers, whether it's the safety data sets or existing assets, whether it's pavement, bridges, ITS, their conditions, criticality, resiliency, the traffic, whether it's recurring traffic or non-recurring traffic, and how do we map that to projects and TISMO strategies? That's where we have had some good success, and that has powered some of our decision making and investments in the past. So what is driving the GIS data governance and policies are the data development component protocols, the Department of IT data sharing and security management policies, the application development templates and policies that we have in place, and also the enterprise GIS data inventory. Again, here are the resources. I won't go through the details of it, but very well thought out protocols that have the policy standards and procedures to not only collect, but manage, disseminate, utilize, and archive our enterprise data sets and solutions. And the approach to data governance, again, we have the guiding principles, the organization structure by data class, whether it's geospatial data, tabular with locations, data streams like the CAV data streams, and also the documents, policies, and standards and procedures for data development, management, storage, and application. So the idea here is we have created some GIS transportation portals that for real-time operations, for work zones, for situational awareness, of internal staff and also external players. So what does this all look from a next generation? Michael talked about the opportunities with the Waze type of data feeds, and how are we gearing up to leverage some of these, and what does it mean from a data management and data governance with these unique data feeds that are coming to us. So we entered into a partnership with the Waze. Again, there is a new name that Michael was suggesting the last fall. And we are a little late to the game, but we have already started leveraging the partnership that we have, consuming the alert data, the jams data, the unusual traffic data feeds that we get. But at the same time, our statewide operations center, our TMC supervisors also post road closure information, work zone information that provides that official verifiable information from a DOT perspective. So these are the small wins that we are already taking advantage of, leveraging this partnership. But here, what we want to use Waze data is mainstreaming traffic incident detection. Can we get to an incident faster and sooner and clear them if we have situational awareness through Waze data? Can we look at our traffic signals timing plans? Is it doing a good job? What does the road weather management situation look like? How do we leverage some of the new data feeds that are coming with the icy roads possible? How can we inform our work zones and maintenance activities? We also look at this as a good communications and outreach vehicle for disseminating information for major projects, special events, and us being the Baltimore-Washington region, there is a lot of focus on the emergency management, evacuation planning, special events category of things. But as simple as going down to the nitty-gritty of it, can we ease the conversations, the correspondence, whether it's a pothole repair, a guardrail repair, the signpost, malfunctioning signals, light, ITS assets. So can Waze become that platform in which we provide our customer with this new opportunity where they can interact with us, and more importantly, they are not going to yet another data stream to put in a ticket for traffic agency intervention. So these are the huge opportunities that we see for ourselves. And where it all ties in is that this is a high-level framework, and this is what we are working with the Federal Highway team headed by James Collier and Paul Jordan to create, through EDC5, to create this proof of concept, to look at the opportunity areas that I highlighted below before, and how do we leverage our existing enterprise data streams, our traditional mobility data streams, but including these crowdsourced streams to not only effectively manage and operate our system, but also looking at our asset management and our traffic incident management and other strategies. So with that, this is, again, we feel that this is a very exciting area for us, because here is an opportunity to directly take advantage of the partnerships that we have with the private sector, having that interface, that direct customer interface, so we are not jumping through the hoops as customers, and having that two-way communications with our customers, stakeholders, and partners. With that, I thank Federal Highway again for the opportunity, and we look forward to the dialogue as we make progress. Back to you, James.
All right. Thanks, Subrat. Very interesting and informative look at statewide level of data management and governance. So a lot of tidbits in there, and interesting. You indicate support from the governor level, similar as Michael indicated support from mayor level at the city in Louisville. So very important having that high-level champion. So just a reminder, please type in any questions you might have for Subrat in his presentation in the chat pod, and we'll answer them as we go and make sure we cover them at the end. Nilo, do you mind pulling up the last poll question here? And just getting pulse one more time. And the question here is, does your agency have a data governance or data management plan? And you'll probably see it's a little bit, the answer is a little bit biased. If you're a state DOT, then you have 4 options at the top. Or a city or MPO or local agency, you have 3 options towards the bottom there. And check whether you have a high-level governor or mayor-level plan, a DOT-level plan, or operations team-level plan, or no data governance plan at all. And I'll just pause a few seconds to let people think and answer that question. Christine, looking like majority state DOT folks do not have a data governance plan, and city MPO, it's a little bit more evenly split with the majority having a city or county level plan. So it's definitely an emerging area. Area is needed as we get into more and more data sources and the world of big data. Okay, thanks for answering that. You can go ahead and close that out, Nilo, and I will introduce our last but not least, our final presenter, and that's Benjamin Peixo from AEM, and he's going to talk about industry-wide best practices as well as trends in data management. So at this point, I'll turn it over to you, Ben.
Thank you very much, James. Hope, Nilo, you can confirm that my voice is going through correctly. I hope so.
Yes.
Thank you. So I want to introduce more of an approach to data management and a little bit on the governance side that comes from what you hear from the Google, the Waze, the Here, and all these companies that are dealing with large amount of data coming from different sources and how they approach it. So what we'll be talking about is a quick reminder of what data management is, kind of like a comparison between the traditional and modern challenges. The data lifecycle phases that we typically find, and then we'll go into some kind of statements about pretty much how you deal with the creation of data, how you store it, how you use it, and how you share it by looking at this lifecycle that is often found in data management. So what is data management? Well, according to the DMBOK, the official definition of data management is the development and execution of architecture, policy, practices, procedures that properly manage the full data lifecycle needs of an enterprise. And there's 11 data management knowledge areas: architecture, modeling and design, security. I'm not going to name all of them: document and content, metadata, warehousing, and business intelligence and metadata. And these are pretty much following what's called the traditional data lifecycle, which goes through the creation of data, the storage of data, and that's what that little circle to the bottom of the slide shows. The use of data, the sharing of data, the archiving and the destroying of data. So this is what typically is done traditionally in I would say what refers to data warehouses that are powered by relational database, such as the one you find from various vendors. So one thing that is happening, and this is only one angle that's coming through the crowdsourced data, but it's also happening in the hardware and software and the skills in the software. There's an increased velocity of obsolescence, which means that defines the time it takes for a technical product, service, or even a data set or a piece of equipment that produced data to quickly become outdated. And this has actually consequences that are legal, that are regulatory compliance risk, that are vulnerability and security, that create IT, oops, I think I lost my screen. Oops. Sorry about that. That creates pretty much data silos or lack of skills and supports and how to cope with the obsolescence. So this is a challenge in data management that has been going on pretty much since the year 2005, and early on from people like Google. The 2000s when this started, but in the people that deal with large amount of data or very diverse and changing rapidly types of data, that's such as the one you find from crowdsourced data sources. And a quick example was the price of hard drive for storage and how quickly it pretty much dropped from 2019 to 2017 for 1 terabyte at 12 cents. That dropped at 4 cents for 8 terabytes and still going down. So what this did is that it created a more simplistic and different approach and augmented the life cycle to handle not only what is now or what is supposed to be there, but what is likely to come in the future and being able to adapt to it by not compromising the data management process and pretty much what is done, and at the same time building a reactive aspect to it. And pretty much the store and archives are only becoming the same. That's what happens. And often the destruction of data because of the low cost of storage is pretty much going away unless I would say the data is maybe 20 years old or completely irrelevant to the purpose that you have. Whereas in typical traditional system, you would pretty much, with crowdsourced data, you would exceed the storage of some of the systems you have very quickly and have to destroy it or archive it. So the create is pretty much split into 3 categories. You have existing data that the DOTs have or emerging data sets that are being controlled, so different devices and things like this. And this can come in the form, this is pretty much come in the form of raw data that pretty much the agencies have control all the way to the source and can control the sources as sensors on the road. You have existing and emerging third-party data, such as the Waze data source, the HERE data source, the crowdsourced one that we're talking about here, that are only accessible to a certain extent and cannot necessarily be controlled all the way, where the quality, the assessment of the traceability of the data is much more difficult to get. And then you have the new domain that is pretty much the edge devices, what's referred to IoT. That's your connected cones and things like this that are going to come that are some sort of crowdsourced data that will be difficult because they process some of the data on the edge at the location, and it's difficult to assess what kind of quality or where the data comes from. So the data practices for the modern data practices for the traditional data sources that you control is that pretty much the data is collected as is and is not modified before it's stored. But the quality is pretty much assessed, and for each record, the quality is pretty much assigned to it or tagged to it, rather than bad quality data being destroyed. The data needs to be open. It cannot be in a proprietary format. And there needs to be some kind of lineage in order to trace what piece of equipment created what data, in order to quickly identify where the source of the data problem comes in. And the data cannot be segregated. It has to all be pretty much collected and put in the same area in order to pretty much create some possibility to merge the data and for example, compare weather data with the sensor data in order to figure out if the troubles you're seeing on some data comes from weather event, for example. And this is important when you're monitoring the sensors. Like for the third-party data, such as the crowdsourced data that you get from Waze over here, one of the clear understanding is the purpose, the lineage, and the value and the limitations of the product. As everybody that tried to negotiate some contract with Waze, though it was fairly restrictive at first, and a good understanding of the quality and establishing pretty much some kind of metrics to monitor the quality of the data that you're getting is a very important and needs to be negotiated. The third party needs to also be augmented. So one of the ways that it's being done is that it's always recommended to assess the quality of crowdsourced data against other types of data that you have, could be crowdsourced data or others, in order to identify where flaws can be, because there can be flaws in the crowdsourced data by nature, not necessarily because the third parties are doing it, it's just because the reporting has changed, for example. And a good communication channels and contract clauses during the contract that you have will be able to allow that. For the edge devices, the most difficult part is the fact that part of the data is processed at the edge, and you get only some pre-processed data towards your data centers. And in order to do this, and in order to keep pretty much an understanding of what happened in case of failure, you would need to pretty much store a little bit, a few minutes of raw data that was ingested by the device in order to do quality assessment, to troubleshoot errors in case of that they have, and to detect, for example, abnormal behaviors and slow drift, which so often happens on sensors that are at the edge. One thing that needs to be taken into account here is that these devices, these IoT devices, are very different than the previous one in the sense that they are pretty much meant to be disposable. And then the moment they drift, they can be pretty much taken offline and then have to be replaced quickly. And for that, they need to be inexpensive. So that is to be kept in mind when you're doing the data management, that you need that ability to shift devices very quickly, where you can have various versions of the different types of connected codes, for example, in the same data feed. Now for the store data, this is a bit different, where traditionally in traditional system, pretty much you store data that is really organized. In this type, you store the data before it's organized, as is, with augmented, some kind of augmentation of the data to talk about its provenance, to talk about its quality, and talks about its meaning and its discoverability. Pretty much that is what's happening here. And this is where the bulk of the data management in modern architecture comes from. So typically, the traditional system is the little square in orange that you can see on top here. What you would have is some kind of structured data comes in. It's being filtered, cleaned, and prepared to be into the storage of the relational database on which you have reports. Now, the modern one, you would have structured and unstructured data that would just be loaded into some kind of storage that is often referred to as a data lake. And things are changing now, but pretty much could still be called a data lake. And then different process, kind of like what Subrat was referring as the data cube early on, can be deployed on top of it. But these are completely independent. And I would say inform the data, shape it to their need and to their level of quality and their level of understanding for each of the applications they support. That could be different places in the organization based on their means, based on their resources, based on their understanding and their interest. The data can be shaped and used to the level of detail and the level of quality that is suitable for them. And this approach is called schema on read versus schema on write, or schema last, where you inform the data and shape the data after you collected it. And this is in order to keep the fact that the data can change, and then these can change independently from each other without having to redesign the relational database every time something changed. Typically, you would want the storage to happen in a cloud solution. Could be on-premise, could be hosted, but usually when you deal with very large amount of data, it's better to have it hosted. Has to be inexpensive, no filtering, and some kind of isolation for very sensitive data needs to be put in place when there's strong security requirements. It could be through a secure kind of cloud hosting as well. The data management is typically done not through a relational database system with a schema that's already informed, but more through something that's similar to a file system on a regular desktop, where the files are just stored under some kind of hierarchical structure, and then they have a meaning in there, and they're also tagged. And each folder structures a different access policies and allows people to go add more data and read the data, but often not update the data. The data is updated often by adding new data and giving a new version of the data rather than updating the data where the old one was. And accessibility to the raw data whenever it's authorized or secure is often better if it's supported by open file formats. And another aspect of the data management is making sure that anybody that builds some kind of analytic system on top of that data need to be able to find the data and to understand what the data means. And for this, you need some kind of searchable metadata repository that represents all the data sets you have in that storage. Same thing, you could use open file compression standards, shy away from the proprietary one in this case in order to limit the amount of storage you use. And you need to track pretty much and monitor who of your end users is accessing the data, is reading the data in what, to make sure that your policies are not being violated. For the use area, so this is something where before you used to have, one or two tools to create reports, dashboards, and all the interactions were going pretty much to some fairly small groups of advanced users within an organization. This is changing a bit with the modern approach where you have a lot more users and you have a lot more data and you have a lot more tools involved in the use of data. Proper management for this process is by, of course, educating the users, kind of like what Michael was talking about earlier, to base derive decisions from the data and use an effective software development cycle to create new data products or new data sets that could be used by others in supporting the architecture in order to do this. I keep pushing on my keyboard. So this is a quick chart. I'm not going to talk about it too much because it's a bit too long. But pretty much it shows that prior we had the big oval in the bottom. What the relational database were up to a certain volume of data, which is the ovals are pretty much using the volume as they go higher, the more data they can deal with, and the two lines are pretty much the value of data. And non-relational database systems have pretty much taken over in order to process data really fast, such as the in-memory GPU database, and are able to derive value from data within microseconds very quickly. And then on the historical side, the Hadoop-based systems or SQLs have been able to derive increased value of the data in aggregate, with going to like 10 years or 1 year and much larger volume of data than relational database have. So for each use cases of analysis, now you have multiple set of tools that can be used, and they're all different. They have different architecture and they rely on different hardware between to support their analysis. In order to do this, in order to support this, the data management and data governance needs to allow data analytics to be performed into different, using different tools, from the simplest one like Power BI to a very large, neural network analysis on very large data, or in the loop with some real-time data feed currently. What needs to be monitored is the quality of the products that are being generated and the responsibilization of the people that create them. Interestingly, compared to the traditional ones, every single one of the analyses perform its own ETL, and it's a custom one on demand pretty much every time it needs to get new data. It's not being done ahead of time and then they just take the data they have. The data tools are pretty much moved where the data resides because the data is way too large to be able to be moved to the tool. A lot of time when you have a lot of data or you need to go really fast, distributed algorithm needs to be used, and there are limitations that need to be well understood on how those modern algorithms work. Sometimes they're a bit fuzzy. Containers and microservices are usually used quite a bit in order to develop those data analysis products, and this is something that is often a bit difficult to understand because they have an ephemeral nature where they're pretty much instances in modern data system where data pipelines, if you would say, or data support systems are only instantiated whenever they need to be. And in modern system, actually, even network connection to connect the data to the processing only happens whenever a call is made, and after that they're being dismantled. There is an ephemeral nature of it. And overall, for this analysis, typical traditional proprietary softwares are being shied upon, and cloud services and open source solutions are preferred. Now, for the shared aspect of it, which is typically what you used to have through a typical data portal like you have now, used to be FTP, and what you now have to go beyond this and pretty much allow access to the data and make sure that the data is not risky and not exposing you to potential problems both for internal and external users. And the data is often shared on a cloud service so that it could support the fact that many people with the typical keywords for this is called many eyes can look at all this data and all this complexity and size and be able to extract as much value of it as possible. Access to a dashboard or a report or some aggregated kind of data is often not enough in order to derive the most value and justify the need to process the data and store it. So one of the aspects of doing it would be to store the data into cloud environments that are pretty much able to be, where that data is able to be read by external users or other internal users that can then develop their own analysis or their own statistics on top of it, and even monitor the quality of that data themselves if they want to. And so at the same time that they're developing tools, this data, the tools or the results of that data can also be shared. Either their process for doing it, their scripts, their programs can be shared as well. And the resulting data that they're deriving can also become part of it. But because of the use of cloud services, pretty much the process of computing on that data or analyzing that data becomes their burden, but not the burden of the agency anymore. The agency just pays for the storage. And it's pretty much what is currently limiting the sharing is that they're really worried that opening this will pretty much max out the capacities of most of their systems. And so a lot of the sharing also requires the use of strong encryption methods that needs to be used. A few of the commonly recommended encryption methods in order to obfuscate data that is sensitive if it's put to the public are currently being challenged where they can be decrypted. Things like SHA-1 and MD5 can be decrypted in 24 hours right now, even though they're still recommended by organizations like NIST. They should not be used anymore. Complex or restrictive standards that are very difficult to parse, like SOAP and XML, should be replaced by things like REST and JSON. The data should be pretty much provided in read-only formats. And the responsibility of the maintenance of the data is the responsibility of the people that produces that data. And I think I'm going to stop here. I just had a little summary at the end. James?
Okay. Thanks, Ben. Great
You're
presentation. Lots of good information on data governance and where the industry's at. And Ben's full presentation, along with all the speakers, will be available for download, as well as the webinar recording on the NOCO website later. So let's see. Nilo, can you pull up the final poll question? And as we're doing that, just a quick reminder, this is a good chance to type in any questions you might have for Ben or any of the speakers in the chat pod. And while you're thinking, so this is, you may have heard me say earlier that the last poll question was the last poll question, the final one. I'm sorry. This is actually the final poll question, I promise. So this one is open-ended. What topics would you like to see in future installments of the Adventures in Crowdsourcing webinar series? So any ideas that you might have or what your agency or your region might be interested in learning more about how crowdsourcing can be used to advance operations, both from a real-time perspective and from a use of archives for planning for operations. Feel free to type it in here. We try to make sure that the topics are of interest and meeting the needs of agencies out there. So we'll use this information as we go about prioritizing and selecting future webinar topics. So, let's see, okay. Disasters, emergencies, evacuations, that's a great idea. Arterial TSMO initiatives such as signal timing, yeah, that's a good one as well. We do have plans to do a future webinar on signal management. quality control, post-processing techniques. Okay, excellent. Let's just leave that up for a few more seconds, see if anyone else has any ideas. Okay, a couple more. How stick groups can help counties and municipalities embrace this EDC initiative. Yes, it is a very important role of the STIC, State Transportation Innovation Councils. Every state has one. It's a group that gets together and decides how they can help advance initiatives under the EDC program. Okay. Good. Well, we're recording these answers. We don't tie it to a specific user, so don't worry about that. It's all anonymous. But we'll use these answers to help us prioritize future webinars. So thank you very much. So Neela, we can go ahead and close that poll question. So now it's this is a time we had to set aside to do Q&A. I think, as I've been trying to track the discussion, that Michael and Subrat have done a good job of answering the questions that have popped up in the chat pod. Let me ask Subrat or Michael, are you good? Or anything else you want to add to the responses that you provided already?
I'm happy to clarify anything if anyone has any follow-up questions.
Okay. I'll have Subrat answer the question from Stephanie. So here's a question from Vaishali. Are the Waze systems and analyses in Louisville real-time? And what is the time lag? So looks like a question for you, Michael.
Yeah, it's real-time. So we basically, well, I guess you always need to define real-time, but it's every 2 minutes. So we hit the Waze feed every 2 minutes and save that. And once it's saved and processed, which just takes a few seconds, then it's available for querying. So we do have we have an API layer that is currently in beta, but it lays on top of the database. So people can hit that, we can hit that API layer with an application to extract, let's say, the most recent, hour or minute or half hour's worth of data, depending on the application. Or we can hit it with a SQL query to get the data out as well. But yeah, it's pretty much real time. The Waze feed itself is even more real time than that. They recommend every 2 minutes, but if you look at it, even second to second, it changes and updates. So you can hit it as often as you need to.
Okay, great answer. Let me just highlight at the bottom of your screen, you might notice below the pictures there's a download pod where the individual presentations you can download. Click on those. They'll also be available later on the NOCO website. There's also the last thing to download is the EDC5 crowdsourcing workshop flyer. So that's just a one-pager introducing the crowdsourcing workshop offering that we provide, and a little bit more information about what could be covered. So if you download that, take a look. If you're interested in hosting a workshop in your area, you can contact me or anyone from the EDC team. There's also useful links box at the bottom as well, the NOCO website and newsletter, NOCO webinars, NOCO on Twitter, EDC5 crowdsourcing page, and NOCO case studies. Okay, one more question from Vaishali. Have any of the presenters found problems with data quality, and are they employing proactive data monitoring or cleaning? Let me just open that up to any of the presenters at this point.
So this is Subrat. The answer is yes, and it depends. So when you're looking at data quality, you're looking at it from the context of end use as well. So I'll give an example of data coming from the RTMS detector. So depending on the level of calibration, that same device can give you occupancy information, and it can give you good volume information as well. So depending on the business needs that these data streams are, or these devices or data streams are serving, that tends to dictate the quality. So in our case, I would say if you went a few years back, you would look at the detector data. It was calibrated for occupancy really good, but not so much as volumes because we were not using that information for planning or traffic analysis. So, and that's where it goes to the multiple uses of data and of the same products, and that's where data quality becomes an important matter. And with that CMM framework where we look at the data streams, we look at quality from the perspective of the end use of that application as well.
Okay, thanks, Subrat. Ben or Michael, anything to add?
Yeah, this is Ben. Yeah, I could add on to what Subrat was saying when he said that the quality is often dependent on the end use, and it is difficult, but it's one of the role of the data governance team and the data management to kind of identify generic ways of qualifying the quality of defining the quality of a specific type of data that is relevant to, I would say, not just the use cases that they have in mind, but the use cases at large, what could potentially be done with the data, but more focusing on what the data meaning is, and then pretty much tag the data with this, but don't filter it or don't do anything, and that really will allow, because some applications will be able to lose very low quality data, or just like Subrat was saying, one application is okay with this level of quality and another one's okay with this level of quality. And in a crowdsourced environment, there's going to be a wide range of quality variation. You're going to have to support the needs on one side and the variation on the other side.
And Ben, if I could just add to that, again, if you're looking at the DOT data streams and all, I mean, the DOTs, we have been collecting data through our own business processes for a lot of years. That's where the data governance structure and the data stewardship structure helps, where you have the planning, the engineering folks, the operations maintenance folks, the stakeholders, all in that committee structure where they are looking at the same data sources and saying, okay, hey, I never thought I could use this data stream if it could only do X, Y, Z. So and that's where the governance structure and the membership, making it multidisciplinary, becomes very important, because those were opportunities missed in the past because folks were looking at it from their own business needs only. So when we started the TISMO conversations where we were looking at planning, engineering, operations, and maintenance as one package, then you started looking at those data streams and saying, oh, how can we make it better? That way it not only serves the operational needs, but it also serves the planning and performance management needs.
Good, thanks. Thanks, Ben and Subrat. Good. We'll probably talk about that one another 2 hours, but let's go ahead and move on for time purposes. There's another question here from Stephanie. Is security a big issue in crowdsourced data governance? I guess you could take that different ways, but any thoughts on that one?
This is Ben. It all depends on the nature of the data you're having. It's in most of the time with crowdsourced data, it's the PII nature. The more you end up having, data that allows people to be identified, the more you may expose yourself to some issues. And obfuscation methods, encryption methods. So I would say in a lot of cases, you do not necessarily need all that information. But it is, the more granular you become, the more difficult it is not to have the ability to trace information back to, I would say, a single individual or a single vehicle or a single cell phone with very, I would say, dynamic and detailed and granular data sets. And currently, the way to, I would say, deal with this is pretty much to try to limit the amount of history or to try to obfuscate some of the fields and to only restrict the access to PII to a limited number of people. And this is done either by creating a copy of the data set that has not been trimmed, that is only accessible to people that have clearance, I would say, to go see that data, or by pretty much applying, I would say, more advanced obfuscation methods. And this is more the type of things you would find in genetic data, because some of the data is by itself pretty much sensitive, and you cannot really obfuscate it or truncate it. And therefore, often there's methodologies where you split the data into 2 data sets or 3 data sets and try to make it difficult to pretty much patch it back together. So the value of the data is still there, yet the exposure to sensitive data is not accessible without very heavy computing, let's say.
Okay, great. Thanks. And I hope that answered your question, Stephanie. There's different ways to think about that question, but it is definitely a big issue and perception of that issue. So we have time for one more question, and luckily enough, we have one more question here, and that's from Ravi. Has crowdsourced data been used to estimate traffic volumes on roads, especially in rural areas?
So I can take a stab there.
Okay.
So we have had a research project with University of Maryland, and then there was another collaboration with the national, the NREL. So the idea was, can we use INRIC's origin, destination, trajectory data to estimate annual daily volumes for Maryland roadways. So the good news there was we were using our ATR and RTMS detector wherever we had volume information coming from our system as our control totals, but we were using the sample INRIC speeds and OD trajectories to estimate traffic volumes on roadways. I could tell from the findings is for the high volume roadways, those because you had more samples, your estimates were much better compared to less traveled rural roadways. Now, I guess once you start mainstreaming some of those data products, then those estimates on the rural roadways would also go up. So I believe there was a Federal Highway EAR project that was looking at how would you use big data to estimate traffic volumes. I would that would be something to follow up on as well. But we find this is a promising area, so we are kind of generating some modules internally for our mobility reporting. So when we generate a annual delay metric, it accounts for the fact that there were less travel days, there were high travel days, there were a lot of incidents on our roadway that impacted demand and travel patterns. So that estimation becomes, takes your data products and your performance measures to the next level.
Great. Thanks, Subrat, and feel free to contact Subrat directly if you want more information about that research project. I think it's really the next big thing with crowdsourced data is if we can get to the point where we can estimate traffic volumes. So that would be, look out for the results of that research. So at this point, I want to thank, again, all of our expert presenters. You all did a great job. And I also want to thank the audience for making the time to learn about data management for crowdsourcing. Great questions. Just the last couple quick things here. One is, showed this quickly earlier, but there are 2 funding sources for being able to test and pilot more EDC type of innovations with crowdsourcing for operations. One of those, STIC incentive program and the aid demonstration program. Consider a kind of seed money, if you will, to both standardize an innovation throughout your state or through the aid program to deploy an innovation that's maybe not currently used and to pilot or demonstrate it in your state. So check out those links for more information. And then finally, that's just contact information for myself, James, and my co-lead, Paul Joden. If you want more information about crowdsourcing for operations, feel free to contact us, and more information on the websites and web links below at the bottom of that slide. So with that, let me just ask Nilo, any final comments you'd like to make on behalf of NOCO?
No, that's all. Thank you, James.
Okay, thanks Nilo and NOCO for hosting this website, and again, thank you everyone for joining, and hope you all have a great rest of your day. Thank you.
Thank you. Have a good one.